and welcome to the webinar about using intelligent PIDs in your daily work. My name is Christina Rech, and I am Product Manager for IntelliPID within UPV and also for other applications in our portfolio. The topics that we have on the list for today are, first of all, a general overview of IntelliPID for those who maybe have not yet seen it. And then I will talk about a few use cases. One of them is to organize from the PID side a quantity management for valves. The next one is how is it possible to work with commissioning systems within IntelliPID and UPV. And the other ones are about PID redlining, which is a general interesting topic. And the last one is about how can you use IntelliPID to perform instrument retagging, which is a task that happens quite often, that instrument numbers need to be changed. I only have a few slides, and then it will be followed by a live demo. The quantity management for valves is a topic where I will show you that it is possible to add additional information to a dataset coming from an authoring tool. In this case, the authoring tool is SmartPID. You can see here the white attributes which come from SPID, and then you have yellow attributes like commissioning system, like valve type, and these can be modified on top of the data that is already available from SPID. Eventually, you can also activate a color coding which refers to the values of those additional attributes. And you can generate reports based on all the attributes which are inside the system. So in this case, we can generate a report which will show for each pipe run the piping component types, the valve types that we have defined via IntelliPID, and then for each different size of the pipe run, there is a counter which can list how many components of that type are available. And this is very valuable information for later on. The second use case is about working with commissioning systems. In this case, we can select a part of the graphic even with multiple components. It can also cross several PIDs. We can assign values for commissioning system, and then we can create reports based on that assignment, and we can also create color-coded PDF documents where all the components have the associated color coming from the list of the systems. This is in use for a large group of companies, and we have also spent time to improve it and to make it more fast, and also the document generation was improved. So it's really a powerful function within IntelliPID. Another use case that is quite important is the possibility to create redlining on top of the PIDs. So in this little example, we have added a new pipe run. We have placed components on the pipe run. They also have their own properties that can be displayed via labels and attribute values. And from the original graphic, it is also possible to hide objects so that the sketch will only represent what the user wants to see. And that sketch can be used in different other departments. It can be printed out. Also, the list of components can be generated as a report. And then it can be delivered to the design team, which is using the authoring tool to modify the PIDs at certain points in time. The last use case I'm going to show is the retagging of instruments. Everyone knows that this is a quite cumbersome task. You have people sketching the PID, they put in original numbers, and later on another group is responsible for the let's call it the real numbering of those instruments, eventually also changing the instrument type, adding additional instruments. And all this is possible if you use a custom attribute with a new sequence, eventually another one using also the modifier values. And then you can mark the changes on the PID. You can generate a report where you will see the instrument tag and the new sequence, eventually the drawing name where the instrument belongs. And all this can be then delivered back to the design team. So, as you see, there is not much introduction. We will now step out of the slides and go directly to the application. And I will start with an overview of the main functions. So, as you know, UPV is a tool which can visualize both 3D and PID data. We can also associate additional documents like installation documents, maintenance documents. And from the 3D system, if the corresponding object is found on the PID can be opened just by clicking on the link. But of course, it is also possible to open the PID directly here from this drop-down list. So I could open a second PID, I can click on an object, I can see the values of that object, I can go back to the first one, click on a pipe, for instance, and I can see the data for that object. And as you see, most of the objects, they have a link to the other side, which means I could click here and go to the corresponding pipe on the 3D side. I can select a component on the 3D side and use the link to go back to PID. But also, I could select a complete group. So let's take maybe these two pumps. And in addition, the valves and pipes that are here on this side. And also now we can use the linking to 3D. We can see here complete systems. If we want, we can highlight them so that the rest displays in gray. And as you see, these are very powerful functions which correlate the PID with the 3D data. Another powerful function that I want to show you is the search function. If we search, for instance, for D240, it will find the object on the 3D side and also on the PID, and I can click on this name attribute. Automatically the tool points to that object and selects it. But I can also look on the PID side. There is an equipment here as well, and if I select it, it will open. So it's really pretty easy. I also want to show you if I would search for a fluid system like P, it will tell me that on the PID side, the P is available in 4 drawings. I can open each one separately, but I could also click directly on top of the attribute, and then automatically a few drawings will be opened, and in each one, the corresponding fluid system will highlight. And for each of them, I could even use the link and jump to the 3D side to see those objects which are highlighted now here on the 3D side. So as you see, the search is very powerful and it can bring all the desired results, and you can very easily find objects within UPV and also, of course, IntelliPID. The next thing which I want to show is the possibility to create reports. So from both sides, PID and 3D, it is possible to generate reports. I have some reports which are already predefined. So if I want to see the equipment list for the active drawing, I can click on this report. If I want to see a certain pump, I can activate it here together with its motor and highlight it. But I can also very easily change this report so that it doesn't display only what is in this PID, that I see all the equipment elements. And then, of course, I have a much longer list, which refers to other drawings. And then I can click on information which seems interesting. And if I want to know where is it in graphics, I again can use the highlight command. And it will show that these are the 3 trays which refer to this column. And I can very easily find them within the PID. What I also want to mention is that the attributes that you see here in white, they come from the source system, which is SPID in this case. But you also see some yellow attributes like commissioning system, like additional comment. If I click on a valve, it will be called valve type. And these are attributes which we can put on top of the data coming from the authoring tool. And with this data enrichment, we can fulfill a lot of scopes. And in the next few minutes, I will show you some of those. So we are going to start with the use case valve management on the PID. We will have a look at the data that you see here. And we will just select some valves and give them a valve type, which is a select list. So I will assign these few valves to type 1. I will select other ones and assign them to type 2. And the drain valves that we have here, we can select and assign to type 3. So now we have done this definition. And if we activate the color by double-clicking on the attribute, you see that the colors will change according to the assignment. And from here, it is also possible to create a report. This report is called valve MTO. And as you can see, this MTO is looking at every pipe. It is looking at the different piping component types and discounting those based on the assignment that we have done and based on the size of the pipe run. Yeah. So for instance, if we want to see where are these gate valves that have type 3 here and we have 2 of them, we can just select the line. We can jump into the graphics and we will see our selection. But also it is possible from here to change an assignment. So if I would decide that this valve has, instead of type 1, for instance, the assignment to type 2, I can make the change here. And when I go back to graphic, as you can see, the valve will be modified to the pink color because it has now the assignment coming from the reporting interface. And also here, of course, it reflects the value that we have defined in the report interface. So it's really pretty easy to do such assignments. And it's also pretty easy to generate a report which consists on one side on data coming from the authoring tool and which can be enriched with attributes that are defined directly in UPV. And of course, I can take this report and I can save it to Excel so that I have a document which I can hand out to my colleagues, eventually to other departments, with the information that we generated within UPV. I will now switch to the next topic. I will deactivate the valve assignment so that everything kind of changes back to normal. And now we are going to start with commissioning system assignment. We will start down here, select the complete area, and assign these values to commissioning system 1. Then we will take the heat exchanger plus the pipe going out and assign it to commissioning system 3. we will use the OPC to go to the other drawing and make the assignment here as well to system 3, and then eventually take the pumps here on top and everything that is right side of those pumps and assign this to system 2. So this is now the assignment. We can activate the colors with two methods. One of them is to activate it directly by double-clicking on the commissioning system. The other way of activating the colors, which is more powerful, is to load it from what we call a display style file. And in here, we have the list of commissioning systems. We can assign them all. And in that case, it will be done for both open drawings. And as you see, not only the color has changed, but also the thickness of the line got a double factor after this assignment. And if we want to do it separately, we can revert the colors and we can assign only one system. So for instance, only the blue one. And as you see, now we got the assignment only for the blue one for both drawings. And of course, the result of all this can be exported to a PDF. So I'm only going to export the current PID. And then we also have a document where this assignment is visible. And you can see the blue color also in the document. But it is also possible to generate PDFs with more than one file which refers to a certain system. And if we have a look at the reports, there is one for commissioning systems. And you see here we have on the left side the list of the systems, and then all the objects which belong to that system, and of course the PID to which the objects belong. And also from here, it is possible to eventually change a value for a system, and it will be reflected in graphics. So this is what I wanted to show you regarding the commissioning system assignment. It is a very powerful possibility, and I think multiple users, they already use it quite intensely. The next topic I want to show is how can we add information to our graphic. So we are going to create a sketch, and I am changing the color so that it's a red line with red components. And here I will start by creating a new pipe. In the new pipe, I will place a pump and on each side a valve. So these are standard objects for sketching, but it is also possible to generate and activate a catalog where we have different types of objects. Yeah, so in this case, I decided to only use this circle. And now, if we don't want to see a part of the graphic because it's too crowded or we don't need it in this sketch, we can just select some components and then we can deactivate them with the hide function. And now we can proceed further and assign attributes to our object. So for instance, I will call this pump P100. I will drag the attribute so that it's visible here below the pump and deactivate the leader line. And then I will click on the valve and I will drag its name, which of course can also be modified down here, and the next one here. And as a last step for the sketching, I'm going to use an instrument from the catalog, because here we need a pressure indicator, and we are going to call it PI with the sequence 144, and we will connect it with the pipe. So as you see, this is our sketch. We can save it. If we close it, the deactivated lines will automatically be visible again. If we activate it, they will disappear and we will see the sketch. And in case we also want to mark up the complete thing and call it pump station or whatever, we can do that. So I'm going to use a red markup line. I'm going to place it here. And then I will place a text inside. And now we have completed our sketch. It consists of the sketched objects, hidden objects, and also the markup. And this is what we can later print out to PDF, send to other people, which at a certain point in time might put it in the authoring tool directly in the system, and then we can regenerate another export of the drawings and continue to do the work. So this is what I wanted to show from the redlining point of view. Now we are going to deactivate this sketch, and we are going to create another one. I will call it retagging. And in this sketch, I'm going to change the color. And then we will have a look here, and we will work on these few instruments to start as an example. So as you see, if I click on one of these instruments, it has this instrument sequence, which I can use to key in a new number. I will call it 2255. I will do the same for the other one. And I will give this control valve a new number 055. And now we could go ahead and just drag those numbers so that they are visible near our modified objects. And if we also want to mark those changes, we could take, for instance, a square and put a square on top of the original instruments so that it's obvious that there was a modification done over there. And this is now something that, of course, we could print to PDF. And it will take the color and the graphic that we placed on top and also show it on the PDF, as you see. And of course, if we hand out that PDF, we can also create a report that goes with it. This one is called Instruments Retagged. It displays the list of instruments from this PID, and as you see here in the second column, there is the new sequence. So if we don't know where one of these is, we can use the highlight to navigate into the PID. But we can also use the list to modify values from here. So if we want to change this to 077, for instance, we can do that. And then from here, we can jump into the corresponding graphical object. You see that the sequence is already available, so all we have to do is drag it to the right position, which is, let's say, here, and then place the rectangle in case we want to do that. And it's really pretty easy to make these modifications in a PID sketch. And if we close the sketch, we can activate it again if we want, using that I symbol. So now again we have activated our instrument retagging sketch. But of course we could also activate the other one, which contains the graphic that we have created additionally the redlining, and if necessary, we could also activate both and generate a document where both information are available. For the sketch that we have created, what I also want to mention is that the sketch items, they are available in a list. So here in this list, you can click on the pump, it will highlight. You can click on one of the valves and they will highlight. And if you double click, it will automatically zoom to that part and it will show the object in a zoomed interface. So these are also available for reporting and not only in graphics. When a sketch is active, it is possible to create a report which will also list the components that were placed with their attributes. So in this case, it would be the name attribute which was used for giving those components an item tag. So this is what I planned to show you in the live demo. And we can revert to the slides and we can jump to the next one, which is a thank you slide. So thank you for your attention. I hope you have learned something new by watching this webinar.